So can we start the group C? Can you hear me?
Hello, doctor. Yes, we can.
Hello. Okay. I have a question.
Yes.
Group C.
Yes.
You are 1, 2, 3, 4, 5, 6, isn't it?
Let me see.
6 students. Is it correct?
We are 6 students. Yes. 2 of them at first you add, but they didn't attend. We don't know what are they doing.
Okay.
Yes.
I need the sequence. Who start and who are continuing? Who is the first?
I'm starting, and the name of the others I don't know the other students, but I will say the name of that maybe. If it's
Amir Mohammed.
the first
Amir
one is
Mohammed.
me, Amir Mohammed Qurbani.
Okay, the second one.
The second one, I think his name is Omru. I don't know. I'm not. Let me see. Let me see the names because I don't know the students.
But it is important.
Yes, this one. He wrote his name.
What is the name?
Okay, professor. My name is Amr Khattab. I'm the second one.
Your name is?
Amr Khattab.
Wait a minute. What's the first name?
Amir Mohammed Qurbani.
Amr.
Okay, Amir Mohammed.
Yes,
Amr Khattab.
Not Amr No, the second one is Omar Khattab. That one is nothing. The first one is Amir Mohammed Qurbani.
Amir Mohammed Qurbani, this is you are. And Amir, there is another Amir, but this is not in my list.
No, professor. He is just AMR.
Amire. Okay, Dr. Amire.
I have in the list Saleh, Ahmad, Abdul Rahman.
Yes, Saleh is here.
Muhammad Ali Abkar.
And the other one is Muhammad Faya.
This is not in the list, but
how is this? How is this, professor? I'm on the list, and we send you the mail.
So who is Amir Khattab?
Yes.
But why you are not in the list?
Doctor, if you want, make me a moderator. I can share my PDF. You can see the names.
I will do that, Amir. So moderator. So Amir, you are the moderator now.
Okay.
So the Amir Khattab, what is the student's number?
I wrote here, second page. Let me show this one. This is the names except Ahmad and Muhammad Ali. I don't know these people. They didn't attend. Maybe they are not also at the class. The other students are attending.
So sorry, Savid. I need the student's number of
Amir, please wait, Amir. Please wait, Amir. Okay, professor. This, if you can see the slide shown in the screen, you will find our student IDs.
I wrote all of the students' numbers.
This first one Amir Khattab. Okay,
First
the
one, Amir
number
Mohammed
is
Qurban.
okay. Say, wait, please. Okay, this your student's number is 2103-10204. Is it okay?
Yes, it's okay, professor.
So you are the second one.
Yes, yes.
Okay, the third one.
Mohammed Faye.
Mohammed. So there's no Mohammed site here.
Mohammed Faye. Mohammed Faye.
Mohammed Faye.
Faye, evet.
Is not in this group. Now the group consists of Amir Mohammed Korbani. Now I've written Amir Khattab, Saleh Ahmed, Ahmed Nail, Abdul Rahman Mohammed, Munfir S. Eldaor, and Muhammad Ali Ebakar. Ebkar. This is the group.
Maybe it's a mistake, but I'm in Group C.
Professor, we sent you this presentation like a month and a week ago, like 5 weeks ago with these details.
Okay, but I mean, okay, but we shaped the groups at the beginning. I mean, why change it?
We don't change it actually
We
because
didn't change.
actually we don't know each other till now. This your arrangement or your shape for the group. Actually, I don't know anyone in the group till now. Yeah, we're just chatting to prepare
Wait.
the presentation.
Wait.
Doctor, for Mohammed Faye is at which group?
Wait, please. Oh, it's not what I want. So now you bring everything. I mean, it's chaotic situation. So I lose the time. So I don't like this.
Just one person, and I'm sure if we check the last recorded, we can see Mohammed Faye is at Group C.
Yes, sir. Maybe it's a mistake from you, but according to your slide, I'm in Group C.
So, and who is the third one? Mohammed Faye, you said?
Yes. Yes.
So the Mohammed Faye is the third one. Okay, the first one, the next one,
Abdul Rahman Muhammad Ahmad Hassan.
Ahmed Hassan. Okay, 4. Next one,
Uh, Saleh.
Saleh Ahmed.
Yes.
Okay, and the next one,
Mondir.
sorry,
Mondir. Yes.
Montir S. R.
Yes.
Eldaor.
Exactly.
6. Okay, and the
The
next
other
one,
two guys, they didn't attend. I don't know.
okay, Ahmed Nail Muhat
And
Musallam
yes,
is it
he is
also
not
available?
attending. He is not
Not.
available, and
Okay, and Muhammad Ali Abkar,
yes, and this guy.
is it in the group?
He is in the group, but he didn't attend nothing.
Okay, we didn't see that. Okay, so you are 6 now, isn't it?
Yes.
Okay, then we will start now. Okay, let's start with first one.
Okay. Hello, everyone. My name is Amir Mohammed. Table of contact. The subjects: introduction, electromagnetic and mechanical actuators, and the other subjects, which I want to start by. The main thing is, what is actuator? My camera. What is actuator? Actuator is a part of device or machine that helps to make the energy or converting the energy. It's converting the electrical, air, or hydraulic energy to mechanical energy. Simply put it, in component in any machine that enables moves or movement. There are different types of actuators that are classified by how they enable energy conversion. The type of actuator, as we can see in the right side and downside, which I will read: hydraulic actuator, pneumatic actuator, thermal actuator, and electrostatic actuator, and electromagnetic. These are the main things of the actuators, the main actuators. Advantages and disadvantages of these three: hydraulic, pneumatic, and electric actuators. Advantages: first of all, produce very high force and power in hydraulic, and the advantages of pneumatic is versatile and customizable, and cost effective, and safe. The electric actuator is easy to maintain, high level of precision. Just these two, it's enough for electric actuator. And disadvantages is, for hydraulic, vital nature, requires highly trained machines. And for pneumatics, disadvantages is compressor must run continuously. It must work too much. And for electric, the disadvantages is the less cost effective than pneumatics, a strict working environment, no fail-safe position if power lost. Is this next page? Electromagnetic mechanical actuator. electromagnetic and mechanical actuator. As we can see, the different types, different parts of these actuators. It's so general. We can see pulley, clutch, and these things for this electric. For mechanical, and here for electric is the main important thing is output shaft. It's going in and outside. The electromagnetic mechanical actuator. Electromechanical actuator are mechanical actuators where an electric motor has replaced the control knob or handle. The rotary motion of the motor is converted into linear displacement, which I said in the last part, by that shaft. And the principal operation in most electromechanical actuator is based on the inclined plane concept. The threads of the lead screw and used as a ramp that convert the small rotation force by magnifying it over a long distance. It means it helps to make a big distance by a low force, so few force. This enables a giant load to be moved over a small distance. They are used in various applications, such as control system, robotics, and automation. These are the applications of the electromagnetic and mechanical actuators. And the timeline of some electromechanical actuators I want to is from the 1965 until 2016. We can see the process, how it becomes more new and with better technology. We can see the second one, as we can see so many in the life. This one is garden tractors and farm equipments. They are using the electromechanical actuators, as we can see here. And next page is my friend. He will read it.
Okay, Professor, can you make me a moderator? Or David, Amir, will you still moving the slides or?
Yes, yes, I will see. No problem.
Okay, okay, just 1 minute.
I have to go to next.
Okay, can you see me now?
No, I cannot see, but I can hear you.
Okay, Professor. Now I will talk about the governing laws of electromagnetic actuators. Electromagnetic actuators are governed by three basic laws. The first of them is Faraday's law of electromagnetic induction, which is a basic law that describes or predict how magnetic field will interact with electric field to produce electromagnetic force, electromotive force. The second governed law, Lorentz force of electromagnetic forces. This is a force exerted on a particle charge or a charged particle moving between an electric field and mechanical and magnetic field. The third law that govern designing an electromagnetic actuators is Biot-Savart law, which is an equation describes the magnetic field that can be generated by a constant electric current. Amir, can you go to the next slide? Okay. The design approaches of electromagnetic actuators. There is two design approaches. The first one is direct problem, and the second one is inverse problem. In next slide, I will show explain in some details. So, Amir, can you move to the next slide? Okay. In direct problem, we are given the dimensions and structure of the actuator, and we have to calculate some some characters like torque or flux density. We can use in this approach some softwares like maybe SimFluid, maybe ANSYS Fluent, which is based on finite element method. This approach will give us more accurate values so that we can. No, Amir, please return back to the the previous slide. Okay. This approach will give us some accurate data so that we are not in big need to make a prototype so that it's a cost-effective solution. With the next slide, in the inverse problem, Amir, please return back. Okay. In the inverse problem approach, we are given the characteristics values, and we have to find the structure and dimensions of our desired actuator. We can use sometimes we can use direct approach and inverse approach together to give more satisfying result and more accurate results. Amir, can you move to the next slide? Okay. In the introduction, my friend Amir has explained some advantages and disadvantages of the electromagnetic actuators. Here, I will explain some details on them. The first advantage of the electromagnetic actuators, they are reducing the size. They reduce the size of the electromagnetic, the whole. What can I say? The whole device or the whole machine, they are very small in size, so it is a benefit of it. They reducing the maintenance cost as we can exclude compressors and some other parts in the actuator, so that we can the total maintenance cost will be reduced. In addition, advantage for these electromagnetic actuators, it improving the machine performance. Amir, can you move to the next slide? Okay. But although they are have many advantages, there is some disadvantage for these actuators, for this type of actuators. Firstly, the electricity costs. Also, they reduce the maintenance cost, but still there is a problem, which is the electricity cost. You can also system build costs may be somehow may be a problem also. It is sensitive to vibration. It has high speed, less thrust. The velocity, it needs velocity and acceleration needs. Non-explosion proof. Force requirements need some force requirements and the responsiveness. So it has some advantage. It has also more limitations, which I discussed. In the following slides, my friends will come to explain the other topics in detail. For now, thanks for listening, and I move the mic to Abdul Rahman. Thanks, Professor, and thanks, my friends, for listening.
Okay, thank you. Yes, Mohammed.
Hello, everyone.
Mohammed, can you start? Hello, can we continue? Hello, can you hear me? So if not, we can continue with the next one.
Hello, sir. Do you hear me?
I can hear you. So can you hear me?
Yeah, of course.
Okay.
I'm going to talk about relays and solenoid actuators.
Who is you are? I mean,
I'm
your
trying
name
to,
is?
yeah, I'm trying to share my video.
Okay, share please your video.
I think there is a problem with the video.
So who is the next one?
One minute, sir, please.
Okay.
So it is that you are sharing, but I don't see myself.
You don't see.
It is that I'm sharing my video, but
What is your name?
Mohammed Faye.
Mohammed Fai. Okay. Mohammed Fai. Let's try again. Let's try again. You can present now.
But I cannot share my video. Let me leave and come back.
Okay.
So it is always saying I'm sharing, but I cannot start.
Wait, Mohammed. Mohammed Fire, where are you? I cannot see you in the list. Mohammed Fire, where is it?
It's okay now. It's okay.
I need your name in the list so that I can make you define you as presenter.
It's okay, sir. I'm sharing my video.
Okay.
Yes, it's okay. I can start.
Yes, please.
Yes. Hello, everyone. I'm sorry for this issue. I'm going to talk about relays and solenoid actuators, and after that, my colleague will talk about the remaining actuators. Amir, can you go?
Okay, Mohammed, let's continue.
Yes. A relay is regarded as a binary actuator as it has two stable states. Relays are either energized and latched or de-energized and unlatched. Relays are those devices which can be turned off or on by the application of low voltage across the relay terminals. Relays are commonly found in automatic control applications as they are able to control an equipment with the help of electric signals. According to the mode of operation, relays can be classified as normal open or normally closed. In the normal open relays, the contacts are connected when the action terminals are energized, while in normal closed relays it is connected to the power supply when the relay actuation terminals are not connected. We can say that a normally open relay will switch power on for a circuit when coil is activated, and a normally closed relay will switch power off for a circuit when the coil is activated. Amit, can you go, please? Here you can see different types of relays. We can have there is a single pole and single throw, as you can see in the schema. For a single pole, single throw, we have just one input and one output. When the coil is energized, the switch changes state and the current can flow. And in the single pole double throw, we have one input and two output. Therefore, we can control two circuits as you apply current voltage in the coil. We can control the circuits by linking the point C and point B, or linking the point C or point A. And for double pole and single throw, we have two output and we have two input and two output. The input are connected, and therefore if we apply voltage to the coil, we can switch the states of the switch, and we can control two circuits from one relay. And for double pole and double please and for double pole and double throw, we have two output and we have two input and four output, and therefore we can control four circuits. And by applying, for example, the voltage to the coil, we can switch from C1 to B1 or from C1 to A1. And we can notice that the two circuits are isolated, so we can have 4 circuits and control them from one relay. Amir, please. Solenoid actuator. Solenoid actuator is the simplest and most common electromagnetic actuator that produce linear or rotational motion by energy conversion. It consists of a soft iron core, a current-carrying coil, and an armature, a plunger. The soft iron core is placed inside the current-carrying coil, and the armature is positioned in the center of the coil. The coil includes a magnetic field when energized with the current. The magnetic field pulls the armature in the center of the coil. You can see in the picture. I mean, you can go. Different types of solenoid actuator. We can have different types of solenoid actuator according to their it converts energy into linear or rotational motion. A linear solenoid actuator, in linear solenoid actuators, the movement is the plunger is linear. Rotary solenoid actuators, the rotary solenoid utilize ball bearing to convert linear motion into rotary motion. The angular motion can be either clockwise or anti-clockwise. You can see in the picture different form of solenoid actuators, and it's finished for me. My colleague will continue with the remaining actuators. Thank you very much.
Okay, the next one.
Hello, sir. Hello.
Hello, I'm hearing.
Yeah, I hear you. Hello, everyone. Today we'll talk about servo motor controlled actuators. Servo actuators are devices used to rotate it or push part of machine with precision. These servo actuators are used in variety of applications such as toys, home, electronics, automobiles, and airplanes. Next page, Amir. How servo actuators work? Servo system mainly consists of three basic components: a controlled device, output sensor, and feedback system. This is an automatic closed-loop control system. Here, instead of controlling a device by applying variable input signal, the device is controlled by a feedback signal generated by comparing output signal and reference input signals. When reference input signal or command signal is applied to the system, it is compared with output reference signal of the system produced by output sensor, and a third signal produced by feedback system. This third signal acts as input signal of control device. This input signal to the device present as long as 3 is a logical difference between reference input signal and output signal of the system. After the device achieves desired output, there will be no longer logical difference between reference and input signal and reference output signal of the system. Then third signal produced by comparing these above said signals will not remain enough to operate the device further and to produce further output of the system, and the next reference input signal or command signal is applied to the system. Hence, the primary task of servo mechanism is maintain the output of the system at the desired value. Next page, Amir. And this some picture, and this picture explain the standard servo motor. Yeah, the picture explain everything, the components this servo motor. Next page, Amir. Synchronous motor. A synchronous motor has a special rotor construction that lets it rotate at the same speed that is synchronization with the stator field. An example of the synchronous motor is stepping motor, widely used in applications that involve position control. However, recent advances in power control circuitry have given rise to synchronous motor designs optimized for use in such higher power situations as fans, blowers, and to drive axles in off-road vehicles. Rotor back, Amir. Rotor speed and the speed of the stator magnetic field is equal, and this about the function n equal ns and equal 120 f per out of p. Next page. On types of synchronous motors. There are basically two types of synchronous motors: self-excited principles similar to those of induction motors. Directly excited, usually with permanent magnets, but not always. And Saleh will continue.
Yes, can you hear me?
Yes, Saleh.
Yeah. Mir, can you bring back the previous slide? Yeah, as my friend said, we have two types of synchronous motors. The self-excited, using principles similar to those of induction motors, mean they can generate their own magnetic field. But the directly excited, usually with permanent magnets, but not always, meaning that they depend on an external power supply to generate the magnetic field. Okay, next slide. So the self-excited motor, also called a switched reluctance. This type of motors generate the magnetic field needed for rotation using DC excitation, which is supplied by the field windings on the rotor. That DC current on the rotor field creates a magnetic field which interacts with the AC magnetic field in the stator, producing a torque to rotate the rotor. To move the rotor from one position to the next, three must sequentially switch power to consecutive stator winding in a manner analogous to that of a stepping motor.
Salih, your voice is not good, not understandable. And
Hear me?
actually, you are. You are reading from the text. There is no picture. So this is too much text. This is not the aim of the presentation.
Yeah, I mean, okay, but just explaining in detail. Yeah. Next slide. We have the directly excited synchronous motor. The directly excited synchronous motor may be called by various names, like ECPM or just a brushless permanent magnet motor. The design of this motor uses a rotor that contains a permanent magnet. The magnet may mount on the rotor surface or be inserted within the rotor assembly. This is the reason why the motor is called an interior permanent magnet motor. Next slide, please. Next slide. The second type is a synchronous motor. This type of motor is an electric motor which works with an alternating current. This motor mainly works on an induced current within the rotor from the rotary magnetic field of the stator. In this motor design, the movement of the rotor cannot be synchronized through the moving stator field. The rotating stator field of this motor can induce a current within the windings of the rotor. This current will generate a force to push the rotor in the direction of the stator. In this motor, as the rotor is not in phase with the stator, then the torque will not be generated. So next slide, please. Here we have the synchronous motor in details. The stator with the three phase windings, the squirrel-shaped rotor, and rotor bars in the air gap. So next slide, please. Next slide. So the principles of how a synchronous motor working. The working principles of this motor is almost the same as synchronous type motor except for the external exciter. As we mentioned before, the synchronous motor generates a magnetic field from itself, but the synchronous motor requires an external exciter. These motors, also called induction motor, works on the electromagnetic induction principle, where the rotor in this motor does not get any electric power through conduction, as in the case of DC motor. These motors don't have any external devices to stimulate the rotor within the motor. Thus, the speed of the rotor mainly depends on unstable magnetic induction. The electromagnetic field, which varies, can cause the rotor to turn at a low speed than the magnetic field of the stator. When the rotor speed as well as
So, Salih, it's enough. Salih, thank you. It's enough because we don't need to read the text. So please go faster.
my friend will continue.
Okay, who's the next?
Hello, Professor.
Hello?
Can you hear me?
Yes, I can hear you, Montier. Yes.
Okay. I now open the camera. I will talk in short way because the time.
Okay.
I will talk about the stepper actuators.
Okay. Mm-hmm.
One, a stepper actuator or a stepper linear actuator is an electromechanical device which produces forces as well as motion along a straight path. Two, with the stepper actuator, The shaft of normal stepper motor is placed with sorry for that. Replaced with the precision lead screw and rotor type convert to precision nut. Free as the rotor rotates, the lead screw rotates up and down. The precision nut creating linear motion without the need for outside. 4. Stepper actuator can be operated over a wide range of speeds and can be used to drive almost any load commonly incorporated. Next, please, Amir. How the stepper actuator works? In two ways. The first one is where a stepper actuator is driven by stepper motor, driver and/or controller, which provides the instructions to command the stepper actuator start or stop. The driver and/or controller sends electrical signal pulses of the actuator causing the rotor. The second way, by sending electrical pulses and instruction, the controller designs how far and how fast the stepper actuator should be extend or retract. In real time by input preferred on the stepper drive or controller. Next, please. Block diagram of stepper actuator system. There is power supply, HMI, and controller, and PLC, indicator, and/or pulse generator, driver, and stepper motor. There is linear electrical motor actors. What is the linear electrical motor actors? 1. Linear motors operator with an AC power supply and servo controller, which are often the same as those used to rotary servo motors. By the changing current phases, the coils, the polarity of each coil is changed. The fourth one is the rate of change of current controls the velocity of the movement and amperage of current departments of force generated. Next, please, Amir. And there is sometimes of linear electrical actors. 1. Parallel electrical actors. 2. Shaped of electrical actors. They look like the L letter. 3. Great motors. 4. dual engines. 5. Electric farmers or static discs. And the last one, align electrical actors. Those is the reference. Thank you for listening us.
Okay. So we are finished with group C. Okay. So then let's start from D.
It's our group now. Omar is gonna be the presenter for the group.
Sorry?
I said it's our group now. Umar is gonna be the presenter for our group. He's gonna show the
Hello
slides.
hocam.
So, wait. The group C, we are finished, isn't it?
Hello hocam.
So,
Yes,
We
doctor.
are
hello. Yes, okay. Thank you for presentation.
You're
General
welcome.
comment about your presentation. So you have lots of text and less pictures. Actually, in the presentation, you should have more pictures or graph or something like that, but not too much text. And you are reading from the text. This is also not the aim of the presentation. Presentation means you have to show that you know that. Don't read it, huh?
True.
So, okay. So next time, please take care about, huh? And pay attention.
For sure.
Okay, so then the group
Hocam, we are the
D.
group D. I
Hello,
put the
hocam.
name of the presentators on the chat and numbers. You can see. If you
Hello
look at the
hocam.
chat, you can see the order.
One second, please. Are group D ready?
Yes hocam, we are
Yes,
ready.
we are ready.
If you
Okay.
can.
So let's check who's in group D. So according to my list, we have Ömer Belli, Omar
Shuikani.
yes, Amin Ali, Adel Bayraktar, and then Ahmet Burak Gürgen, Altar Toraman, Mert Demir, Görkem Uğraş. Is it correct?
Yes hocam.
Yes, it is correct. Hocam,
Okay.
chat'e attım sıralamayı, bakabilirsiniz.
Sıralamayı as an email or what?
Yo, bu chat'e ya.
Ay-
Yandaki
Hocam
chat'e.
sohbet kısmına.
Sohbet kısmında.
Okay, let's see. So I have please I have to remark it here in my list. So who is the first one? Please tell me.
Yes hocam. Can you hear me? I am first. Omar.
Yes, I'm hearing. Yes, first one.
Okay.
Who is the first one? Group
It's
D.
Omar Shuikani.
Okay, Omar Shukan is the first one, and the second,
Ahmet Burak.
Ahmet
Mhm.
Ahmet Burak Gürgen. Okay,
Third is Görkem.
Görkem is third. Okay,
Fourth is Adel. Adel Bayraktar.
and Adel. Okay, Adel. Okay, four. Okay,
Fifth is
Five.
Mert.
Matt is fifth. Okay,
Okay. Sixth is Altar.
six. Altar. Okay,
Seventh is Ömer.
seven. Amir
Ömer.
and eight. Ömer. Eight. Ömer.
No,
Okay.
hayır kanka.
So,
Hayır hocam. Ömer is the seventh and finally Amin. Sorry for the mistake.
okay, Ömer is seven and
Amin is last. 8.
Amin is the 8. Okay, one. Okay, so okay, let's start with Omar Shuikani. So Omar, let's start. Group D. Okay.
Okay, if you can make me moderator, please, so I can upload.
Yes, I can do that. Omar. Here. Okay. So, go on, please.
Okay, thank you, hocam. I will upload my file. Okay, I will turn on my camera also.
Yes, please.
Okay, shall we start?
Yes, yes, please.
Okay. Hello, everyone. We are Group D, and today we're gonna talk about the mechatronic component that is the sensor. We're gonna go over each type of sensor, and we're gonna discuss how they work and the advantages or disadvantages of each sensor. Sensors are important components of mechatronic system. They allow the interaction between the outside world and the mechanical system, which allow precise measurement and control of various parameters. These sensors can be classified as either contact types or non-contact type, and they can also be branched into binary or analog, depending on the type of signal they provide. Some of these type of sensors that we're going to discuss are magnetic position sensors, inductive positions sensors, capacitive sensors, and etc. And as I said, these sensors can branch into different type of sensors depending on the type of signal they convey. First, we're going to go over the contact type sensors. I'm going to talk about two kind of switches in these contact type sensors. Contact sensors are physical. They require physical contact to detect a change in force or position, which allow actuation in the actuation in the mechanical element using such as switches or buttons, and these switches or buttons can used to close or open the circuits, which allow to send the signal to the mechanical element. The first type of switch I'm going to talk about is the limit switches. These switches are sensors that work using an actuator arm. They are mainly made of actuator arms, contact, and mechanical switches. They work by when the object pull or push on the actuator arm. This actuation is detected, which activates a switch that sends the signal through the mechanical component. And these are commonly used in industrial applications such as machinery control or automation. Second kind of switch I'm going to talk about is the reed switches. These are magnetic switches that consist of two metallic reeds that are contained in a glass tube. When this switch is when a magnetic field is applied to these reed switches, the metallic reeds contact with each other, which sends a signal through which closes the circuit that sends a signal through the mechanical components. These are reliable switches, but they are typically sensitive to mechanical shock and vibration, and they are usually used in security systems and automotive sensors. Advantages and disadvantages for these kind of sensors: they are reliable and simple, which make them low cost, and they can be used in a wide range of application. And because they rely on contact, they don't require external power supply. And some of the disadvantages are because they are contact, they can wear over time with repeated use, and they have limited sensing range, and they also might require maintenance because there's a lot of moving parts. And as I said previously, because they are contact, they can have a lot of wear and tear and damage if they are used for a long period of time. And now my friend Ahmed will continue from here. Thank you for listening to me.
Okay.
Good afternoon, everyone. So we're going to talk about proximity sensors, inductive proximity sensor, and center hysteresis in this part. So let's start. Proximity sensors is a sensor able to detect the presence of nearby objects by generating frequency without any contact with the object. Electromagnetic radiation is emitted by proximity sensor, for instance, and looks for change in the field or return signal. The object being sensed is often referred to as proximity sensors target, depending on the proximity sensor target. Let's move on. So here is the our proximity sensor types. We are gonna talk about inductive proximity sensor in this part. Let's move on. Before starting that, let's look at the switching distance and hysteresis. As you remember, most of us get the mechanical experiment lab one past semester, and we made the experiment in that lab. So we move the object to the optical sensor, like operation in operation distance, and light gets on. When we measure that, for example, we find it 5.7 millimeter. But when we remove the object from the optical sensor, here is this restitution distance. The light gets off at 6 millimeter. So the 0.3 millimeter part is our hysteresis distance. The reason of it, it prevents vibration in the system, because if it wouldn't be, the system would close continuously. Let's move on. So inductive proximity sensors detects the metallic object which is present next to their active site. This sensor operates under the electrical principle of inductance, where a fluctuating current indicates an electromotive force in a target object. This non-contact proximity sensor detects ferrous targets, ideally mid-slit thicker than 1 millimeter. They consist of 4 major components: a ferrite core with coils, an oscillator, a Schmitt trigger, and output amplifier. As you see in the right picture, shows us effect of a metal target on sensor oscillating magnetic field. When you see the cable coming out of the sensor turn red, it means that metal has been switched on. When the metal goes away, you can see that oscillation returns to maximum level, and the sensor output is switch back off. Let's move on. So, working principle of inductive proximity sensor. The working principle of inductive proximity sensor is based on the electromagnetic induction. The coil will generate high frequency oscillation field. The oscillator creates an electrical oscillating magnetic field that radiates from the ferrite core and coil array at their sensing phase. When a ferrous target enters this magnetic field, small independent electrical currents, these are eddy currents, which are indicated induced in the metal surface. As you can see the right bottom picture, that ferrite core and coil array is at sensing phase. Let's move on. The Schmitt trigger blocks monitors in this picture the amplitude of the oscillator and particular level. The trigger circuit switch on the or of the sensor. If the metal object or target is moved away from the proximity sensor, then the amplitude of the oscillator will increase. You can see in the picture. So let's move on. Frequency range of inductive proximity sensor. An inductive proximity sensor has a frequency range from 10 to 20 Hz in AC or 50 Hz to 5 kHz in DC. Because of magnetic limitations, inductive sensors have a relatively narrow sensing range, like from fractions of millimeters to 60 millimeters on an average. Nowadays, inductive proximity sensors are available with different operating voltage. These inductive proximity sensors are available in AC, DC, also AC-DC modes. These are universal modes. The operating range of the proximity sensor circuits from 10 volt to 320 volt DC and 20 volt to 265 AC. Let's move on. You can see in the picture, image shows the waveform of the inductive proximity sensor oscillator in the presence of the target and in the absence of the target. We can continue. So this charts provides approximate correction factors. As most metals are compounds rather than pure, so effective sensing range achieved will vary depending on the composition. The main concept to keep in mind is that inductive proximity sensors can detect a variety of ferrous and non-ferrous metal, but not necessarily at the same sensing range. You can see steel is 100%, but copper is 30%. So base sensing range is ferrous steel. Other non-ferrous target materials can still be detected by an inductive sensor, but normally at a reduced sensing range. In the chart, you can see correction factor and type of metal. We can continue. So let's look at the applications of inductive proximity sensor. These are machine tools, assembly line, automotive industry, detection of metal parts in harsh environments, and high-speed moving parts. We can continue. So advantages of inductive proximity sensors are it provides us contactless detection. Also environment adaptability, which means resistant to conditions seen in industrial areas such as dust and dirt. Capable and versatile in metal sensing, high switching rate, no moving part, ensuring a longer service life. So let's look at the disadvantages of inductive proximity sensors. It's lacking detection range, averaging a max range of up to 60 millimeters. So it's kind of low. Can only detect metal objects. Also, it's a disadvantage. External conditions like extreme temperatures, cutting fluids, or chemical effects on the performance of the sensor. Thank you for listening.
Thank you. Okay, the next one.
Hocam, can you see me?
Evet, Görkem. Yes, I'm listening.
Hello, I forgot to open the mic, sorry. Hello, dear friends. From now on, I will continue from capacitive proximity sensors. Capacitive proximity sensors detect both metallic and non-metallic targets, and they can detect from powder, granulate, and the liquid and solid form of these. And they can also see non-ferrous materials. As the name suggests, capacitive proximity sensors operate by noting a change in the capacitance read by the sensor. There are 5 parts of capacitive sensor: sensor housing, connection interface, sensor end bell, mounting nuts, and sensing phase. Sensor housing is a portion of the sensor. Thank you. Sensor housing is the portion of sensor provides the means for mounting and protect sensor internals. Sensing phase, the capacitive field created by the sensor emanates from here. Mounting nuts supplied with each sensor. Sensor end bell is the indicator that lets from the environment, and it's appear in this area of the sensor. Connection interface is the equipped with the factory installed cable or built pin connector, etc. Capacitive proximity sensors operates like there are 2 conduction plates like in the schema. They are in different potentials and they sensing the potential differences. And air acts as an inductive insulator, and there is a capacitance occur in both plates, and they detect capacitance detection, and they detect the proximity with the help of that. And we can see the another part of the capacitive proximity sensor. At the top, there are electric field comes in, and sensor electrodes detects the sensors. And in the main part, there are RC oscillators, signal conditioning, and output stage. There are 4 types of capacitive proximity sensors. First one is miniature capacitive sensor. These miniature capacitive sensors, they are in cylindrical shape or wafer type shapes. They package to save maintenance space. These sensors do not have a signal processing circuit inside them. They need a separate other amplifier to process the signals. The cylindrical capacitive sensors larger than miniature sensors, and they can have diameter from 6 to 30 or 40, something like that. And they detect larger diameters. High temperature capacitive sensors, as the name indicates, they detect extreme temperatures, and they can handle direct contact with high temperature objects or fluids. Analog capacitive sensors, they find their applications in material selection, thickness monitoring, and concentration checking tests. The advantages of capacitive proximity sensors are they can be used to detect non-metallic targets. They can detect through containers of certain types. They are simple and easily constructible, and also adjustable to machines, and detect dense targets and decrease. And it's very important, they are low cost than the other ones, and they have higher sensitivity and can be operational with small magnitude for force. The disadvantages of capacitive proximity sensors are they are too sensitive to changes in environmental conditions, and they are not very accurate if you compare to inductive sensor type. The other one is the optical proximity sensors. Optical proximity sensors are used for light detection and implying infrared spectrum of light. They offer a short range of detection, can perceive several types of materials. There are 3 sensing methods of optical proximity sensors: the true beam method, retroreflective method, and diffusor reflective method. You can see the schematic of the operational schematic of the optical proximity sensors. You can see the direction of the person, movement person, and the behind of the sensor there is an amplifier and window comparator. They processor processes this scene and detect the person while he is walking. Optical proximity sensors applies on checking objects on production lines or commerce, like in fabrics or car base bells. Also, they use in counting of small objects, detection of colors, measuring distance. We can enlarge these examples. You can see the working operation of optical sensing. There is an optical source. There are feed fiber and measurement zone, and also there is a return fiber to optical detector. The optical source and the optical detector are works in accordance. There is a transmitter and receiver. You can see the another picture here. There are two light emitting diodes and photodiodes. There are reflecting rays. Here is an object. We can see it like an animal or something like that. They can detect and they can process this object, and they can locate this object. The advantages of optical proximity sensors, and they have high sensitivity, and they are suitable for remote sensing, and they have wide dynamic range. But they can be very costly, and they can be if they can have physical damage, it's very it's not too easy to operate again. Here is my part is finished. Now my friend Adal is continue from now.
Okay, thank you, Görkem.
Hello, Professor. Is my voice and video clear?
Adel, yes, I can hear you. It's okay.
All right. I'm going to be talking about through beam sensors. Through beam sensors, as the name says, they work through transmitting a beam from the transmitter to a receiver. The through beam sensors can be split into two types. First one is reflective through beam sensors and the direct through beam sensors. So talking about direct reflective type, it usually the target that we're trying to detect is made of reflective material. This is how it works. The transmitter transmits a beam and it hits the object, the reflective material object, and it goes back, the beam goes back to the receiver. And once the beam reaches to the receiver, we can know that the object has been detected. Unlike the direct through beam sensor, it's much more simpler. The beam is transmitted, and once the object interrupts the beam, it gets detected. After that, I'm going to be talking about the applications and functions. Can we go to the next slide, please? Yeah. So how are through beam sensors beneficial for us in our daily lives? As we've already discussed, they're useful when it comes to object detection. And in the same way, it's useful when we're measuring the distance between two objects, in the same way that it works for the detection of an object. And we can also know the position of an object in the same way that we can tell the distance between two objects. It can also be used for security and safety. As we can see in this picture, we have beams surrounding a building, and once a human being, let's say, crosses the beam, the sensors will go on. Let's say a safety alarm will turn on, and the alarm is gonna be set off because the sensors have detected the human being trying to cross. And in the same way, we can use this type of sensors to control the traffic, like cars or motorcycles, for example. After that, I'm going to be talking about the advantages and disadvantages. One major advantage for through beam sensors is that the object we're trying to detect does not have to be close to the sensor, because the beam can go pretty far away, so it can detect objects in a long range. It is actually very accurate compared to other types of sensors, and it has a faster response time compared to other types of sensors. The disadvantages would be the alignment of the sensors, also the space requirements, since they take a lot of more space compared to other types of sensors, and the installation and maintenance can be quite expensive as well. And this is going to be my part. My colleague Matt is going to keep going with diffuse reflective sensors.
Hocam, can you hear me?
Yes, I can hear you.
Okay. I'm trying to open my camera. 1 second. Hocam, I couldn't open my camera, so can I go on like this?
Wait, Matt, wait.
Okay.
Okay, now I think you can try once more.
Hocam, video paylaş dediğimde bir şey çıkmıyor ama ben anlayamadım ya.
I defined it as presenter Matt Demir. Actually, shouldn't be a problem.
Bilemiyorum hocam.
Okay, let's continue.
Okay.
Don't lose time.
I will talk about diffuse reflective sensors. Diffuse reflective sensors are type of optical sensors that are commonly used in industrial automation applications. They have built-in light emitter and receiver. These sensors detect the emitted light bouncing off an object and thereby determines if an object is present. So can we move on? Types of diffuse reflective sensors. There are 5 types of diffuse reflective sensors, which is background suppression sensors. These sensors use combination of optics and electronics to distinguish between the target objects and the background. They can detect objects within a specific sensing range and while ignoring any objects beyond that range. Convergent beam sensors. These sensors emit a focused beam of light that converges at a specific distance from the sensor. When an object enters this range, it scatters the light, and sensors detects the change in the reflected light intensity. And polarized retroreflective sensors. These sensors use polarized light source and retroreflector to detect the presence of the objects. They analyze the polarized light, reflect back from the retroreflector, and detect any changes caused by the object's presence. Diffuse reflective sensors with polarization filters. These sensors use polarization filters to eliminate the effects of surface reflections and to improve their accuracy in detecting objects with low reflectivity. Lastly, fiber optic sensors. These sensors use a fiber optic cable to transmit and receive light signal. They are highly flexible, can be used in applications with harsh environmental conditions. Now I will talk about the working principle of these diffuse reflective sensors. They have a few circuits inside, which includes modulator and amplifier stage, transmitter and receiver stage, detector amplifier, and demodulator stage, and lastly output stage. Firstly, let's talk about modulator and amplifier stage. This stage generates a signal to rapidly turn the LED on and off. The signal typically has a shape of square wave. Transmitter and receiver stage. The transmitter is often LED due to its lower power consumption and switching speed. The emitted light is in the visible light and the infrared wavelength range. Red LEDs are most common among the visible light types. Detector amplifier and demodulator stage. Received signal is amplified and further conditioned by filtering and smoothing. Receiver circuit also works in synchronization with the transmitter, reducing further chance of external interruptions. Lastly, output stage. Output stage receives the conditioning signal from the demodulator and switches the output. Now I will talk about application of diffuse reflective sensors. Some of them are object detection in industrial automation applications, presence detection in packing and assembly lines, liquid level detection in tanks and containers, web break detection in printing and paper processing, detection of irregular shapes or size in sorting applications, detection of object and conveyor belts, sorting and counting applications in material handling, positioning and alignment in robotics and machine vision systems. Advantages and disadvantages of the diffuse sensors. Let's start with the advantages of them. As I mentioned, diffuse sensors do not require separate receiver because the reflected light from the objects being sensed activates the receiver. They allow for frontal detection of objects, which means that they can detect objects without requiring a direct line of sight. Diffuse sensors can detect objects selectively in front of a background. Disadvantage is diffuse sensors are not suitable as true beam sensors when accurate lateral response is crucial, as they rely on scattered light to detect objects. They might not be able to detect objects with low reflectivity, such as black objects or objects with matte finish. Now I will give you short information about fiber optic cables. Fiber optic cables are thin strands of glass or plastic fibers used to transmit digital data signals over long distances with high speed and accuracy. Let me give you information about working principle. Fiber optic cables work by transmitting light signals through core made of glass or plastic fibers. The light is reflected off the wall, and the core through a process called total internal reflection, which allows the signal to travel over long distances without losing its strength or clarity. At the other end of the cable, the light signal is converted back into the electric signal, which can then be used to transmit data. This allows the fiber optic cables to transmit data at high speeds over long distances with minimal interference or loss of signal. Application of them: telecommunication. Of course, we say telecommunication, we will think that telephone, internet, cable TV networks. Sorry. Data centers. We can say transmit data between servers, storage devices, medical equipment, military and aerospace, industrial automation, and home networking like speed, reliability, and security. It shows that specifications. Advantage and disadvantage of the fiber optic cables: high bandwidth and fast data transfer speed, immunity to electromagnetic interference, minimal signal loss over long distances, thin and lightweight, making them easy to install and transport, secure and difficult to tap. Disadvantages of them: expensive compared to copper cables, fragile and can break easily, requires specialized equipment and expertise for installation and maintenance, limited availability in some areas, particularly in rural or remote locations. Thank you for listening. Now my friend Altar will go on.
Okay, Matt.
Hocam sesim geliyor mu?
Yes, Altar.
Kameram gözüküyor mu şu an?
Gözüküyor, evet.
Tamamdır. Hello guys. Today I will talk about ultrasonic sensors, pneumatic sensors, and back pressure sensors. Ultrasonic sensors are electronic devices that use sound waves with frequencies higher than the upper audible limit of human hearing to detect and measure distance to objects. Next slide, please. I will explain the working principle of this mechanism. Now, as you can see, there is two output and input. From output, mechanism sends the sound wave signal, and if the sound wave signal hits the object and reflects back, then mechanism understands that there is object, so it's the working principle. Next one, please. Here we have different types of ultrasonic sensors. Proximity sensors, distance measuring sensors, level sensors, flow sensors, and object detection sensors. I will give one example for each one so you can imagine better. We use proximity sensors for in security system for detect the motion. Distance measuring sensors are mostly used in construction industry to align the things. Level sensors are used to measure the level of the liquids in the tanks, and flow sensors for used to measure the flow rate of air in heating, ventilation, and air conditioning in HVAC system. And as you know, object detection sensors we use in our cars. Next one. I explained the applications and functions. Next one, please. Next one. Hocam slide atladık sanırım ama.
No,
Tamam. Pneumatik'teyiz. Tamam. Pneumatic sensors are devices that are used to detect or measure changes in pneumatic pressure or vacuum levels in a system or process. In next slide, I will explain how it works. Here, as you can see, in the left side, there is an input which takes the air and flows it out. So there is no object at the right side of the output. So there are less pressure. Less pressure. So we can understand that there is no object. But in right side, there is object. So we have small area. Small area means big pressure. So we can understand that there is an object. Next one. Types of it: pressure sensors, vacuum sensors, flow sensors, position sensors, and temperature sensors. Pressure sensors are mostly used in HVAC system for air conditioning and ventilating. Vacuum sensors are used in automotive industry for engine control systems, brake boosters, and fuel systems. Flow sensors for manufacturing process to monitor and control the flow rate of the liquids or gases. Position sensor. Pneumatic position sensors are used in various manufacturing processes to detect the position of pneumatic cylinders or other pneumatic actuators. Temperature sensors are used in various automotive applications such as engine control systems and HVAC systems. Next one. Next one. Advantages of it: cost-effective, reliable, easy to use, fast response time, safe, operational safety in dusty area, insensitive to sound waves. Disadvantages: limited range, limited accuracy, limited flexibility, maintenance, limited compatibility. Next one. Back pressure sensor. Back pressure sensor is a device that measures the pressure in a system, specifically the pressure that builds up against the flow of a fluid or gas. In other words, it measures the resistance to flow in a system and can provide important information about the efficiency and performance of the system. Next one. As you can see, in left side, there is a tank and water pours in the tank. And the over of the tank, there is a system. That system, which is has air inside, air comes to the liquid, and if the tube is inside the liquid, so it is harder to go out for air. So we can understand that we reach the level that we want or we don't want. Next one. Applications of it: control of flow rates in chemical processing, food and beverage, and pharmaceutical manufacturing, monitoring of liquid levels in tanks and vessels, control of pump and valve operation in HVAC and refrigeration systems, monitoring of fluid pressure in hydraulic and pneumatic systems. Advantages and disadvantages of it: accuracy, efficiency, easy to install, and cost-effective. Disadvantages: limited range, potential for clogging, requires regular maintenance, not suitable for all applications. Thanks for listening.
Okay.
Hocam merhaba, sesim geliyor mu?
Merhaba, geliyor.
Tamam hocam. Başlıyorum hocam o
Kim?
zaman.
Ömer, tamam
Ben
Ömer.
hocam.
Hadi bakalım. Başlayalım.
Hello, I will explain the reflex sensor and other sensors. Reflex sensors are the optical sensor that work using reflected light to detect the presence or movement of an object. The sensor detects the presence or movement of the object by detecting the reflected light. Next one. Same like. Next. Types: optical reflex sensor and ultrasonic reflex sensor. First picture, optical reflex sensor, and second, ultrasonic reflex sensor. Next one. Application and functions: distance measurement, motion detection, presence detection. Other slide. Advantage and disadvantage. Advantage: fast response time, lower cost, wide range of uses. Disadvantage may be sensitive to light source, poor operating performance on weakly reflective surface, temperature or humidity changes may affect sensor operation. Other air barriers. An air barrier is a device used to separate an area between two different airflows. Air barriers create airflow to prevent outside air from leaking in. Next one. Same like right zone cold place, left zone hot place. Using factory and mall. Same like. Next one. Tips, types, vertical air barriers, horizontal air barriers, water recursion air barriers, virtual air barriers. Application and functions protect the air. Just all. Add and disadvantages. Advantage saves energy by prevent airflow, protect the passage of doors and other openings, easy to maintain and clean. Disadvantage can be costly. Strong winds or air currents can reduce the barriers, affect the winds. High sound levels might be available on some models. Pressure switch. Pressure switches are devices used to activate or stop electrical signal. When a certain pressure level occurs, pressure switches are used to control levels and pressure of compressed air, gas or liquid fluids. Next one. Application and functions: hydraulic system, pneumatic system, water treatment system, air conditioning and ventilation system, industrial automations, food and pharmaceutical industry, fuel tanks. Advantage and disadvantage. Advantage: they can work with high pressures. They are widely used in industrial applications. They have a wide measuring range. Disadvantage: temperature and humidity changes can affect sensor operation, can be costly. Measurement error may occur on some models. Connection and circuit technology. Connection and circuit technology are technology used in design, assembly and testing of electronic circuits. These technologies include interconnection circuit units, assembly of circuits and printed circuit boards, PCB, or other substrates, connection of cables and components such as signal service between components. Semlax. Application and functions: PCB design, soldering, SMT, integrated circuit packing, connectors, wiring. Advantage and disadvantage. Advantage: high productivity, high sensitivity, less mistakes, take up less space, higher reliability. Disadvantage: high price, requires high technology knowledge, it is time consuming during production, high risks, environmental effects. That's all. Next, my friend.
Hello,
Okay.
teacher. Can you?
Hello. Yes, I can hear you. Amin.
Yes. In this part, we'll talk about parallel and serial sensor connection. First one, parallel connection. In a sensor technology, parallel connection refers to connect of two or more sensors to signal port or a control device. When sensors are connected in a parallel, the output are combined, and the result signal is used as a single input to the control device. Here we have many types of parallel connection, such that temperature sensor and pressure sensor, flow sensor, and humidity sensor. In this picture, we have temperature sensor. And the advantages and disadvantages of parallel sensor connection. Increased sensitivity. By connection sensor in a parallel, the sensitivity can be increased. And flexibility. A parallel connection allows the great flexibility in a system design. Different types of sensor can be used to detect the same permanent. And cost effect parallel connection can be cost effect way for of increasing the overall performance of the system and redundancy. And the disadvantages of parallel connection, signal noise and increase complexity and signal interference. Here we have a serious connection. In serious technology, sensor connection refers to the connection of multiple sensors in a series of desired chain, where the output of one sensor is connected to the input of the next sensor. In this configuration, each sensor is assigned unique addresses, and data is transmitted serially from one sensor to the next. Here we have types of serious connection: gas sensor, light sensor, flow sensor, and the pressure sensor. And advantages and disadvantages of serial connection: improved data transmission, scalability, easier data processing, improved performance, and the disadvantages is limited bandwidth, signal interference, and addressing issues. And here we have a summary of parallel and serial sensor connection. Parallel connection of a sensor involves connection multiple sensors to a single input or output, with each sensor operation independently. This can be useful for application where multiple sensors are needed to monitor different aspects of a system environment. And the serial connection of sensor involves connection multiple sensors in a sequence manner, with each sensor transmitting data on one bit at the time over a single wire or transmission line. This can be useful for application where multiple sensors needed to be connected over a long distance. And this is the last part of our presentation. Thank you.
Okay, thank you. So for presentation, slides were good organized. I mean, picture and text, I must say, good balanced. But it takes too long, huh? So because it's nearly 1 hour.
Yes, thank you, Hojam.
Yes.
We went into a lot of details, so our slides were really long, so we're sorry about that.
So,
but I hope you
okay,
liked
then.
our presentation.
Yes, thank you. Thank you for your presentations. It was nice. So now let's start with the group E. We don't have too much time. So the group E. Group D, okay, group E. So group E, please tell me the sequence. Who is the sequence? Who will start, and who is the first? Who is the second, third, and so on? Who's the leader of this group? Group E.
Hocam
Hello.
Furkan, presenter Furkan olacaktı.
Presenter, okay. Furkan. Furkan, öğretici. Furkan, can you hear me?
Evet hocam, buradayım.
So, then you start first, isn't it?
Yok, ben ilk başlamıyorum, ikinciyim.
İkinci, okay. You are the second. Who is the first?
First is Ahmet Haydar.
Sorry?
I am the first one. Ahmet Haydar.
Ahmet?
Haydar.
Fayez. Haydar, okay. You are the first. Okay, the third?
Third is Cemile.
Jim.
Benim hocam
Suat.
buradayım.
Okay, Suat. And Fuat?
Javad el-Haddad. Javad.
Okay. Javad. Okay. And the fifth?
Bulutan Kaplan.
Benim hocam.
Bulutan is fifth. Okay. Then the sixth?
Tayyip Bihter Tünaydın.
Tayyip. Okay. And seven?
Fuat Bayrakçı.
Fuat. Seven and Abdelhak eight.
Hocam
That is
o
correct.
sunumunu yollamadı.
Hiçbir şey
Abdullah is
yollamadım hocam.
Abdullah is not available. Okay. So then, let's start with Ahmet Haydar.
Yes, hello, good evening, everyone. Please, Furkan, if you can put the presentation.
Yes, I will do that. Ahmet.
One second.
So we can start, Ahmet. But each one maximum 3 minutes, huh? So you have to go fast.
Okay. Ben sunum ekleyemiyorum hocam. Nasıl yapacağımı bilmediğim için.
Hocam sunucu Furkan olacak ama Ahmet'e vermişsiniz.
Tamam, Furkan da yapalım öyle. Peki Furkan nerede? Furkan okey. Öğretici al. Furkan yapalım sunucu. Okey Furkan.
Bir saniye. Dosya paylaş. Şu olması lazım. Bir yandan da emin olayım.
Okay, hello everyone. It's Ahmed Haidar here. I'm going to present to you distributed automation systems and computer integrated manufacturing. Next,
Okay.
please. Who is controlling the slides?
I am. Hold on.
Okay, can you?
I'm here.
Yeah, okay. Distributed automation systems, DAS. They are networks of integrated devices and systems that work together to automate and optimize industrial processes. DAS is becoming increasingly popular in industries such as manufacturing, energy, and transportation because it allows for greater flexibility, scalability, and efficiency in automation. Now, some key aspects of DAS. First one, architecture. DAS is typically composed of multiple components, including sensors, actuators, controllers, and communication networks. These components work together and analyze data, make decisions, and control industrial processes. Now, for the communication, DAS relies on communication networks to enable real-time data exchange between different components. Common communication protocols used in DAS including Ethernet, ProofNet, and Modbus. Now, for the benefits, DAS provide numerous benefits such as improved productivity, reduced downtime, enhanced quality control, and increased safety. DAS can also support the integration of renewable energy sources and the optimization of energy consumption. Furkan, put the next slide. Okay. And for the applications, DAS can be applied to various industrial sectors, such as manufacturing, energy, transportation, and building automation. Examples of DAS applications include factory automation, energy management systems, smart grid systems, and intelligent transportation systems. Now the challenges. DIS faces several challenges, including security risks, compatibility issues, and the need for specialized skill and knowledge. Now the compatibility is particularly important because DIS typically involves multiple vendors and technologies. Next one, Furkan. Okay, now let's speak about CIM, or Computer Integrated Manufacturing. CIM is a manufacturing approach that utilizes computer technology to manage and control the entire production process, from design to final product. The goal of CIM is to create a streamlined and efficient manufacturing process that reduces waste and cost while increasing productivity and quality. Next one, Furkan. Okay. Now, some key aspects of CIM. Components of CIM. CIM is comprised of several components, including computer-aided design, CAD, and computer-aided manufacturing, CAM, computer-aided engineering, CAE, robotics, and material handling systems. These components work together to manage the manufacturing process from start to finish. Now, some benefits of CIM. CIM offers several benefits to manufacturers.
Sorry, one second. There's 1 second, please. There's an urgent call.
Okay.
Let's continue, please. Okay, let's continue.
Okay, now for the benefits of CIM. CIM offers several benefits to manufacturers, including increased productivity, reduced waste and cost, improved quality, and faster time to market. CIM can also help manufacturers to better respond to changes in customer demands and market trends. Next one, Furkan. Okay, now the challenges of CIM. While CIM offers many benefits, it can also present some challenges to manufacturers. Implementing CIM requires significant investment in technologies and infrastructure.
But Ahmet, you have to talk about the network system. So this is something, I mean, the abbreviation, which is very common in the industry, computer integrated manufacturing, computer aided design, or I don't know. This is not what we actually defined in this section. So the network system, what are the network system? And it is too much text. There is no picture, nothing seeable as actually the visualization is very important, huh?
Yeah, I'm sorry for that, but our topic about network, we divided network to a lot of sectors and divided it in our team. So each one have two topics to talk about it.
But please summarize it, huh? It takes too time.
Okay, I'm almost finishing.
Okay.
Okay, for the applications of CIM, CIM is used in a wide range of industries, including automotive, aerospace, electronic, and medicine. In each of these industries, CIM is used to manage the manufacturing process and increase efficiency and quality. Now, the future of CIM, as technology continues to advance, the capabilities of CIM are likely to expand as well. The use of artificial intelligence, machine learning, and the Internet of Things are all expected to play a large role in CIM in the future. Overall, CIM represents a powerful approach to manufacturing that can offer significant benefits to companies willing to make the investment. By integrating technology and streamlining the manufacturing process, CIM can help companies to be more competitive and better serve their customers. And that's my section. Thank you.
Okay, Ahmet.
Now it's my turn, Hocam.
Okay.
I'll start then. Yes, I'll go on and explain field buses and AS interface in the world of automation. So what is a field bus? A field bus is can I have a second, please? Yeah, I'm incredibly sorry for that. So a field bus is a type of network, we can say. So a network is the way to connect our machines and everything together in the field, right? And field bus is a type of network. If we are to say that connecting two stuff together, we will first think of something called peer-to-peer connection, connecting two stuff with a cable and they will be equals. But the field bus is different. We use field bus to connect our actuators, our sensors, and everything into our PLCs or other types of controllers like PCs and stuff like that. And the field buses are much more desirable to stuff like peer-to-peer connection because we have one master, let's say, and a lot of actuators and other stuff that we control with that master, which we can do with peer-to-peer connection, but it doesn't make as much sense. So field buses allow several topologies. Topologies in the way of meaning how we connect stuff, right? It can be that I have shown 4 of them together in here: ring, branch, star, and daisy chain. There is also linear topology, and linear topology is simply connecting everything together in a line, and every machine and sensor is also connected to their predecessors, the one that comes before it and the one that comes after it, and they all go in linear fashion. But if the device fails, it is much harder to diagnose, and it is harder to just repair it. And it also has limited scalability. There is also the daisy chain topology, the one on the far right. Daisy chain is pretty much the same as linear topology, but we can also offshoot branches. So for example, it's going in a linear line, and suddenly we can make a branch that isn't connected to the rest of the line. There's the ring topology. Ring topology is that everything is connected in a circular fashion. Our machines, they're all connected to their predecessors, and they're the one that comes after them and the one that comes before them. And it is much more fault tolerant when we are comparing them to each other. This is a much more fault tolerant version, but it is also kind of hard to find if something goes faulty. There is also the star. Well, the image actually shows pretty good at how they are. If I'm not mistaken, the branch topology is also called tree topology. It has a hierarchy. And in star topology, each field device is connected directly to a central hub, or let's say switch. So they're all connected by one line to the center. Going on, I'll talk a little more about field buses. So as I said, the field bus protocol is a type of network. It is mostly just one line, one long cable connected to our PLC or PC going down through the production line. And as time went on, some more new types of field buses have been created. The very first one that I could find in the internet is Bitbus, which is, if I'm not mistaken, developed by Intel. Then there are also Profibus, Interbus, CAN bus, HART, ASI, and MESBus. For MESBus, DIN MESBus, I think it was an abbreviation of something else. It is a German protocol, and there are very limited resources on it on internet in English. Most of them are in German. I can go into detail a little bit on all of these, but I would rather not. We will go into detail on ASI a little bit more. But all of these field buses that I have put in here, these 7, are used widely in the automation sector and any kind of production. If we continue with it, the ASI stands for Actuator Sensor Integrated. ASI in the world of automation, ASI is a protocol that uses the master-slave communication method. So master-slave communication method There are different types of communication methods, but we'll mostly focus on master-slave. So there is a master machine, which is either a PLC, let's go for PLC, programmable logic controller. It gives in the information and collects information and gives orders to all of its slaves. For the slaves, there are sensors that are slaves, actuators are slaves, and everything else. For ASI, physically, if we are defining it physically, it has one cable that carries two conductor cables inside of it. So it's pretty simple. And setting it up is also really easy because it also carries the power through that same line. Both the information and power gets carried through that same line. In ASI protocol, one master can have up to 62 slaves. And well, yeah, it can be used in discrete manufacturing, factory automation, processing automation, or it can even be used in home automation. It can be used in any kind of automation. And it was developed in the 1990s, so when we think about it, it's actually an old technology that is still holding up to today's standards. Of course, it has been changing with time. If anyone wants to just go on into this topic anymore, they can just go into their internet site, at which they explain it through. It has changed a lot with time, but the main idea is simple. It is cost effective, easy to set up, and is cheaper in the end. And a few companies that use this ASI, as an example, one I can give Festo, Siemens, Schneider Electric. If I'm not mistaken, also Bosch uses it. And pretty much any company that uses that uses automation in their production lines have probably used ASI or are still using it. And that's been all from me. Thank you for listening. And it's Cemile's turn now.
Okay, Furkan.
Hocam beni duyabiliyor musunuz ve görebiliyor musunuz?
Duyuyorum Cemile.
Tamamdır. Let's continue with my part. The other page, please. Okay, so I want to talk about conventional solutions and SAI solutions in the network. And in world of industrial automation, and these two approaches are widely used to connect field devices to the central control system. And both solutions have their unique advantages and disadvantages also. So firstly, we'll talk about the conventional solutions. Conventional solutions are the traditional way of connecting field devices. They typically rely on hardwired system to connect devices to the central control system. And in this system, devices are connected using individual wires or bus systems. As an examples of conventional solutions are, the first one is Ethernet. Please, next slide. And okay. The first one is Ethernet, and the Ethernet is traditional technology for connecting devices in a wired local area. Next slide, please. Next slide. And next slide. Okay. And the second one is TSP/IP. Computer network protocols IP obtains for connecting devices in IP obtained the address which data is sent. I'm sorry. And TSP is responsible for data delivery. Next slide, please. And next slide. And next slide. And next slide. We have some insufficient time, so I'm not gonna explain them in too much. And virtual private networks, aka VPNs, are VPN connections disguises the data and protects it. And the next slide, please. Can you go to the next slide? Okay. My voice coming out?
Yes, I can hear you, but can you change the slide, please?
Okay.
Hangi slayda geçmemiz gerekiyor? Şu an birazcık takip edemedim ama.
Either
Cemile bizi duyamadığı için mi çıktı acaba?
so I think you have to try once more because you are not connected as far as I see.
Geri bağlandı hocam. Son şuradaydı galiba. Mikrofonun kapalı Cemile.
Can you hear me now?
Yes, I can hear you, Jim.
Hocam benim mikrofonum kapalı mıydı? Konuşuyorum ama.
Yok, ben sizi duyuyorum.
Tamam, devam ediyorum o zaman. Kusura bakmayın. If we talk about the pros, one of the main advantages of conventional solutions is their reliability.
We don't see the presentation. So there is something missing here.
Next slide, please. Next slide.
Slaytlar gözükmüyor mu hocam?
Yes, I don't see the slides.
Sağ aşağıdan belki görüntüyü büyütmüşsünüzdür. Slide gözükmüyor mu orada?
Evet hocam, bizde şu an görünüyorlar ama.
Size görünüyor peki.
Evet.
One second please. So who is presenting the slides?
Furkan hocam diyor.
Ben değiştiriyorum.
Furkan değil mi?
Evet hocam.
Furkan, okay, you can make the present. I mean, you can show that because you are the sunucu. I mean, presenter. So I don't see that. Maybe see the paylaşım nasıl yok.
Hocam.
Can you try again to share the screen?
Ekran paylaşmıyorum da dosya paylaşarak yaptım hocam. Şeye bakabilir misiniz? Sayfanızın sağ alt tarafında konuşma sayfasının solunda böyle küçük olarak gözüküyor ya konuşan kişinin kamerasıdır vesaire. Orada olabilir mi acaba slide?
Bir dakika bakalım. So, Furkan değil mi?
Yok hocam, bana odaklanırsanız ben şey yapmam. Ben ekran paylaşmıyorum. Ben direkt slide'ı oyların üzerine yükleyip oradan değiştiriyorum.
Peki nereden göreceğim ben bunu şimdi?
Yani tekrar yüklemeyi deneyebilirim. Şöyle paylaşımı durdur desem.
Tamam şimdi.
Dur desem.
Tamam şimdi tekrar yüklersen gelecek o zaman. Tamam öyle görünüyor. Evet. Tamam.
Furkan ileri alıversene hemen kaldığımızda.
Now it's okay, Cemile, you can continue now, okay?
Tamam. Thank you. If we talk about pros, one of the main advantages of conventional solutions is their reliability. These systems have been used for decades and have proven to be reliable and effective method of industrial automation. And additionally, conventional systems are relatively simple to install and maintain since they require a straightforward network of wires. If we talking about the general disadvantages, conventional solutions do have some drawbacks, and they can be time-consuming to install since they require extensive wiring. Additionally, adding or modifying devices in conventional systems can be challenging since it requires adding or removing wires, and this can make it difficult to modify or expand an existing system. Let's move on to the second topic, SAI solutions. Can you change the slide, please? Next one. Go find SAI solutions. Go. Okay, wonderful. If we compare the SAI solutions and conventional solutions, SAI solutions are more modern approach to industrial automation. SAI systems use a single two-wire cable to connect all the field devices and system, and this cable provides both power and communication to devices which are connected using simple plug-and-play connectors. And SAI solutions are used in applications such as process control, packaging lines, and safety systems. As examples of SAI solutions, one of them proximity sensors. Can you go to the other slide, please? Other slide, yes. You can see the proximity sensor types here. And proximity sensors are used to detect the presence of any object without the need for any physical contact. And the second one is actuators. Other slide, please. Okay. An actuator is a device that produces a motion by converting energy and signals going into the system. And the third one is safety switches. Can you go there? Thank you. And a safety switch is a device that quickly switches off the electricity supply if an electrical fault is detected. And to minimize the risk of electricity-related fires, electric shock, injury, and death. And if you look at the advantages of SAI solutions, the simplicity, the single cable reduces wiring requirements and simplifies the installation process if we compare the conventional solutions, and which can save time and money. Additionally, SAI solutions are highly flexible and can easily be modified or expanded as needed. And SAI systems also offer more advanced features and functionality than conventional solutions if we compare them. SAI networks can support more complex devices such as sensors, the proximity sensors that we talked, that provide more detailed data about a process. And additionally, SAI networks can support more advanced control functions such as distributed control and safety functions. And however, SAI solutions can be more expensive than conventional solutions if you look at the disadvantages, especially for small-scale applications. And SAI networks can be more complex to design and configure since they require more advanced knowledge and expertise. The choice between conventional solutions and SAI solutions will depend on the specific needs and requirements of your application, actually. For simple applications with small number of devices, conventional solutions may be more useful. For more complex applications that require more advanced functionality and flexibility, SAI solutions may be the better choice. Thank you for listening. Let's continue with another part.
Thank you, Jamila. Okay.
Hello, everyone.
Hello.
We are to talk about CPX and CPV. What is the CPX? CPX product series of trusted automation values manufactured by first in Germany in 1925 in Esslingen am Neckar, and has since grown to become leading manufacturing of industrial automation products, including pneumatic and electrical actuators, sensors, controls, and values. The CPX value series was introduced by Festo in 2003 as a modular and flexible value system that offers precision control and high performance for industrial automation application. The CPX value is a type of electric control valve produced by Festo, leading global builder of automation technology and industrial training. The CBX value is designed to control flow and air fluids and variety of industrial automation applications, offering high performance, reliability, and flexibility. Next slide, please. The CBX value is known for its model design, which
So
allows.
Gawat, sorry. You are listening from the text. I need the presentation. Please, more picture, more seeable interpretation, but not too much text. You are listening to text.
Understood, so,
please go fast, and I need. I mean, the really. You have to show something, huh? Not the text.
Okay. The CBX value is used variantly in industrial applications such as baking, food, and beverages, automotive, and more. It offers process control of air and other fluids, and it's designed to be easy to install and maintain. The value is also complete with various types of electrical and pneumatic connectors, making it easy integrate into different systems. Please, next slide. Overall, the SPX value is
No, go ahead, please. You shouldn't read it. Go ahead.
Okay. Pass. What's the flow control values and checks value and shuttle valve overview. The SPX value series of a range of valve type meet different industrial automation needs.
So this is a valve terminal. Sorry, Gawat. This is a valve terminal from Festo CPX. That means you configure the valve. Different type of you can connect together with input-output modules with integrated PLC, and you can connect the valve terminals to the network. We are talking about the network, not the components connected to the network. So if we want to continue with CPX valve, so we have to finish now here.
Okay, next.
Do you have something? I mean, the picture and so on.
I don't have a picture, doctor. Next.
So go ahead. The slides. I mean, you change the slides, huh?
Okay, doctor. Sorry.
So finish now. Not CPX. We shouldn't talk about CPX. It's not what we want. Okay. So the next one, Bulutan. You are okay. You make okay. Bulutan. Let's. Bulutan. Where is it? Okay. Bulutan. Okay. Wait. Okay, Bulutan. You can continue.
Comparison of station-oriented machines and comparison of system cost. Comparison of station-oriented machines. When purchasing and designing station-oriented machines, it is important to consider several factors that can impact the machine's performance, efficiency, and cost. These factors include speed, accuracy, flexibility, ease of use, and cost. Speed is a critical consideration when choosing a station-oriented machine. Faster machines can produce more parts per hour, which can increase productivity and efficiency. For example, a machine that can produce 100 parts per hour is more efficient than a machine that can only produce 50 parts per hour.
So, Bulutan, if you want to continue with text and reading the text, we shouldn't do that, huh? So, do you have anything to show? Okay, so please come to the end. It is not what we want, because you have to show the pictures. You have to explain the picture, huh?
Okay.
So not the text and reading the text from the slides. This is not what we want. Okay, thank you. And the next one.
Benim hocam sesim geliyor mu?
Evet, geliyor Taybe.
Bir sonraki slayta geçebilir misin? What is ASI systems? Sensors. Since my friend will explain the ASI system definition in more detail, I want to talk about it with its main line. Actuator sensor interface, aka ISA, is a standard bit-oriented field bus connecting binary sensors and actuators at the lowest process level in automation. It connects simple nodes like push buttons, limit switches, process valves, solenoids, relay, indicators, and on-off devices with PLC or another controller. The interface The interface has allowed replacing complex cable harness entry with an ISA cable, which is a simple, non-shielded, non-twisted two-wire cable. The cable enables transferring of standard and safety-oriented data on the same line. Also, low-power sensors and actuators can be powered by the same cable. In most automation seats, ISI is now the de facto networking solution for the first level of automation due to its simplicity, low cost, and flexibility and safety features. And next slide, please. What is ISI integrated CPV valves? ISI integrated CPV valves typically consist of CPV valves that have ISI communication modules or interfaces integrated into their design. These communication modules allow the CPV valves to be connected to an ISI network and communicate with a central control system or other ISI devices. This integration enables centralized control, monitoring, and communication of CPV valves, providing advantages such as simplified wiring, cost effectiveness, and flexibility, and diagnostics and interoperability. How it works. ISI is a simple and cost-effective communication system used in industrial automation and control that allows for the connection of sensors, actuators, and other devices over a single two-wire bus. What about CPV valves? What is CPV valves? CPV valves are pneumatic or hydraulic valves that are designed to regulate pressure and control fluid flow or direction in a system. They can be used to control the actuation of pneumatic or hydraulic actuators, cylinders, or other devices by regulating the pressure of the fluid that drives them. CPV valves typically have multiple parts and can be controlled by an electrical signal, allowing for precise control of pressure and fluid flow.
But Taybe, sorry for interruption. So you have to add some pictures from the CPU valve terminals. So I know this product very well, but there is no picture, no connections. How do you connect, and what about the connections, type of connections? Nothing seeable. You are dealing with text. I have to stop you now. Can you continue, please? Do you have something to show as pictures? Okay, you finished actually, huh? So thank you, Taybe. I understood what you are talking about. CPV valve terminals use the ASI interbus actuator sensor interface to connect the valve terminals. Certain valve terminals consist of input, output module, and valves. You connect to the network, field bus, or any other bus system. But okay, you can explain the also product connected to the bus system, but mainly you have to show how we connect those type of sensors and actuators to the network system. This is the main issue actually we're talking about. Okay, Taybe?
Geliyor mu hocam?
Benim sesim geliyor mu şu an?
Taybe, yes, you finished now, isn't it?
Evet.
Tamam, Taybe. Okay, thank you. So the next one.
Geliyor mu hocam? Can you hear me?
Geliyor Fuat. Okay, I'm hearing. Yes.
Okay. Today I want to talk about WAV terminal configurator 5.40 and Ethernet dimensions and distributed small controllers in the web. Next slide, please. WAV terminal configurator, it's a software tool developed by Festo, which is a global supplier of automation technology and industrial training. VTC 5.40 is a design to simplify the process of some configuring and ordering Festo's WAV terminal products, which are used in industrial automation applications. Next slide, please. Using this software is useful for engineers and technicians can select from a range of pre-configured WAV terminals or create their own custom configurations using a drag and drop interface. The software provides real-time feedback on the compatibility of selected components and generates 3D models, which is useful for the WAV types. And we have WAVs. Can you move? And one more, please. One more to the WAV types. We have WAV types for first one is the solenoid valves, which is an electromechanical device that is used to control the flow of fluids such as air, water, and other gases and liquids. It works by using an electromagnetic coil to control the opening and closing of a valve, which regulates the flow of fluid through our system. And next one is the pneumatic valves, which are devices used to control the flow of compressed air or gas in a pneumatic system. These valves work by opening or closing pathways to allow or block the flow of air or gas. There are different types of pneumatic valves, like direction control valves, pressure control valves, and as I remember, flow control valves. And next one is process valves. Can you move? Yes, and process valves are a type of valve used to control the flow of fluids, such as liquids, gases, and slurries. In a process system, there are different ways to do that, like gate valves. There are globe valves, ball valves, and butterfly valves.
Fuad, sorry for interruption, but you talk about the valves. Actually, we have to talk about the network. This is the topic, not the valve. So, do you have anything about the network?
Yes. After that, we have Ethernet dimensions.
Okay, please go fast.
We move to the Ethernet dimensions, yes. And as an Ethernet dimensions, first of all, we have to know the Ethernet. Our friend explained it previous slides, but I also explain it. Ethernet is a family of computer networking technologies that is widely used for local area networks, LANs, and WANs. And this is this is from IEEE standards based. We can see here the data rate, cable type, physical connector, maximum cable length. This type of dimensions decided by IEEE and used in the worldwide same because we have to use this same standards to communicate easily and understand each other. This is really important for the computers. And after that, we have distributed small controllers in the web. which is a concept that refers to use of small network controllers in the distributed control system that can be accessed and monitored via the internet or web-based interface. That's all, Hocam.
Okay, thank you, Fuat.
Thank you, Hocam.
So the next one.
Hocam,
The next one.
Hocam biz zaten son gruptuk da bir şey söyleyebilir miyim?
Bir dakika. Fuat bitirdi. Ha, bitti mi? 8 yok mu? Ha, yok.
Yok hocam.
Yok hocam, o hiçbir şekilde bir şey paylaşmayan bir arkadaş vardı o.
Yani sadece
Tamam,
görüldü attı
okey.
yazdıklarımıza.
Evet hocam, hani hiçbir şey göndermediği için eklemeye gereği de duymadık ama konumuz da bir tık yarım kaldı onun parti olmadığı için.
Anladım. Okay, peki. Tamam o zaman. So, what I want to say regarding your presentations. So, please, if you prepare a presentation, you have to present actually the more picture, more graph, more table, but not too much text. Text, and you shouldn't read from the text. Okay, you can write some sentence, some maybe words to remember certain topics or to, let's say, the keywords, so that it can lead you what you have to talk about, but not write lots of text and read from the text. This is not the presentation. Do not it again, huh? Okay.
Peki hocam.
Okay. So, any question from your side, from the group E?
Hocam ben bir şey söylemek istiyordum ama
Buyurun.
hani siz resim ekleyin demiştiniz ya, benim konum ASI Integrated CPV Valves olarak açıklayacaktım. Ama onunla alakalı fotoğraf bulamadım. Yani ya sadece CPV Valves'in fotoğrafı çıkıyor.
CPV valve terminals. There are lots of pictures. You have to visit the website of the Festo.
Ha, yani sadece
There's lots
valve,
of CPV valve.
hani yanlış bir
The
şey de eklemek
configuration
istemedim.
of sorry?
Yanlış bir şey de eklemek istemedim. O yüzden bulabildiğimi
No,
ekledim.
So please, if you check the website of the Festo or let's say the CPV valve terminals into
tamam.
if you check in internet, you will find lots of the pictures regarding the CPV valve terminals. CPV valve terminals is a terminal consists of valves, pneumatic valves, and input modules, output modules, and the communication modules. That means the field bus communication modules, or even if it is master, it can includes the PLC as far as I know, and also some nodes which you can use to connect to the other bus systems. So there are lots of information about it. It's a interesting topic.
Teşekkür ederim hocam.
Okay. You're welcome. So the group F.
Yes, Professor.
Are you ready?
Yes.
Yes. You are ready?
Yes, hocam.
Okay. Let's so according to my list, there is who are in this group. Ahmad Awad, Atil Yusuf Amir, Ali Mertcan, Atilla Çağatay, Demirhan, Ümit Ali, Muhammed Khalid, Ahmet İsam ve Musa. So please, who start first? You should give me the name, the number.
Musa hocam. Last one.
Okay, Musa.
Yeah.
Musa will be the first. Okay.
Yeah.
Second one.
Second
Hello,
one.
who is the
1 second. Yeah, Professor. First one Musa. Second one
Yes.
Atil. Atil Yusuf.
Sorry,
Second one, Atil Yusuf.
Atil Yusuf is
Yes.
second, okay.
Third one, Muhammad Al-Lahwani.
So wait, Mohammed Lahwani. Okay, this is the third one, Mohammed.
Fourth one,
Lahwani. Fourth, Ahmed Isam.
Ahmed Isam, yes.
Okay, this is fourth. And fifth?
Only these members. Other members didn't want to present.
This is not available, not participated.
Yes. Yes.
Okay, then wait, please. You are only four. Four member, huh?
Yes, four member.
Okay,
Four
let's
members.
wait,
Yes,
please. 1 second, okay. Demirhan, Odayak, okay. Okay, then let's start with Musa.
Yes, Hocam.
Okay, I'm listening, Musa.
Okay, just if you can give me a moderator so I can join, I can share.
Yes, I can, yes. Sure, I can do that.
Okay. One second, Hocam. Okay. I'm trying to share my my screen. One
Okay.
second, I'm sorry. I think now it's sharing.
Okay, yes.
Yes. Today, me and my friends, we are going to present the PLC hardware, the programmable controller logic system. This is the content that we are going to speak about today. So basically, what is PLC hardware? It is a programmable logic controller. It's specialized in type of industrial computer to design and to control the automation industrial process. And it include a process and input and output, of course, and a memory and communication boards and power supply. Now I will speak in a short way how it work. So basically, it's include a processor and an input and output device and a memory and a communication board and a power
Musa,
supply.
sorry, Musa, can you use the whole screen? I mean, for the PowerPoint?
I don't know how, Hujam. Oh, yes,
So
I think it's,
this,
yes.
Must be something, okay.
Now it's good,
okay.
right?
Yes, it's okay.
Yeah. So now I will speak more specifically about the process. So it's the brain. The process execute the program logic and generate the outputs. So the input and output, these models are used to interact with the physical world. They receive signals. Signal forms, sensors, and other input device, and it's generate signals as well to control the actuators and other output devices. And the memory is including RAM and sorting program data to store the input and the data and the configuration that we want to save in our device. So when we select PLC hardware, there are several considerations so we take in our consideration. First of all is the performance. Second, the input and the output. The input is required of system will determine the number of input and output modules that we need in our system. This include considerations such as number, digital and analog input and output, communication protocols, and specialized models for specific function or application, as well as in the environmental factor of PLC hardware. It configures the temperature and the humidity and the vibration which the PLC hardware will be used and take it under consideration. I will speak more about the programming software. The programming software that we use in PLC hardware is also important to consider. The software should be user-friendly and innovative and have features such as debugging tools and simulation capabilities. Last thing, I will speak about the cost. The cost of hardware should be considered, of course. The hardware should be effective while meeting the necessary performance and functionality requirements. Long-term costs such as maintenance and support should be also taken under account. Now I'll speak more about the PLC configuration. First of all, we select and approach the PLC hardware and choose the type of PLC hardware that best suit our requirements of industrial process that we need. And we need to automate it. Can you hear me?
You can. Yes, I'm hearing. So you can continue. Okay. Not too much text. You explain just. Huh? You can go fast.
Yeah, I'm explaining.
Musa?
Okay.
Yeah.
Actually, Muhammad Al-Ahwani, he will do this part.
So my part is finished?
Yeah, actually, and the last part for Atri.
Okay, Hujam. So my part is finished. Sorry for my mistake. I will... 1 second.
Musa, keep sharing your screen so you can...
Yes, I will close my camera and... Yeah. 1 second. I'm sorry. Yeah, I think now it's back. 1 second.
Who will start now?
Now it's my turn, Hujam. Muhammad Khalid Lahwani.
Mohammed
So
Khalid,
let us
did I miss
continue
you?
with PLC configuration.
Sorry, you are the second, huh?
Teacher, actually, I am the second one, but
Yes,
my friend
Attila
Musa was going
was second.
fastly.
Attila.
Musa was read my parts, so there is some problem, I guess.
So Musa
Atal,
was the first.
if you want, we can divide my three slides between me and you because Musa read Atal part.
Yes, so
Yeah.
continue with PLC configuration parts.
Yes,
But I
yes,
can see
continue,
the
continue,
slides.
Atal,
There's
continue.
problem.
So who is
Okay.
continuing, Mohammed or Atil Yusuf?
I'm continuing. Atal Yusuf.
Okay, Atil Yusuf, let's continue then.
PLC configuration. The PLC configuration, for the PLC configuration, select the appropriate PLC hardware. Choose the type of PLC hardware that best suits the requirements of industry process that needs to be automated. This is our first one. For the second one, install the PLC hardware. Install the PLC hardware in the location where it will be used. Third one, install and configure the PLC software. The PLC software is used to program the PLC to control the industrial process. Install the appropriate software on a computer and configure it to communicate with the PLC hardware. And other slide, for the develop and test the PLC program, develop a PLC program using ladder logic or other programming languages that are supported by the PLC software. 5, download the program to the PLC. Once the program has been tested and validated, download it to the PLC. 6, monitor and maintain the PLC system. Monitor the PLC system to ensure that is functioning properly. Make adjustments as necessary to optimize performance and ensure that the industry process is running smoothly. Yes, my part is done, I think.
Okay, you finish your
Yes,
part?
Hujam. Now I will continue. Muhammad Khalid Lahwani.
Mohammed is continuing now, okay?
Yes, third one.
So, okay.
Moving on to materials, programmable logic controller, which is PLC system, typically consists of several components, including hardware and software. Here are some common materials used in PLC systems. 1. PLC hardware. 2. Programmable software. 3. Input devices. 4. Output devices. 5. Communication cables and connectors. 6. Power supplies. 7. Mounting hardware and accessories. As the no, just go back one. So as the graph shows, here is some materials included together for the input, user memory and data memory, and for the output also. Go ahead. So moving on to the PLC software. A programmable logic controller. Software is programming tool used to create, modify, and monitor PLC programs that control industrial processes. PLC software can vary depending on the manufacturer, but typically includes the following features. 1. Programming interface, which is defined as the programming, used to create, edit, and manage PLC programs. It allows users to write code using a variety of programming languages, such as ladder logic, function block diagrams, structured text, or sequential function charts. Second, simulation capabilities. The simulation feature allows users to test PLC programs before they are downloaded to the physical PLC. It enables users to identify and fix programming errors before they occur in real-time production. Finally, the debugging tools. PLC software often includes debugging tools to help identify and correct programming errors. This may include setting breakpoints in the code, viewing variable values, and stepping through the program line by line. Fourth, I/O configuration. It is a tool that allows users to set up and configure and input the input and output devices that the PLC will control. This may include setting device addresses, configuring communication protocols, and setting up scaling and range values for analog devices. Fifth, communication protocols. PLC software typically includes support for various communication protocols such as Modbus, Ethernet, and Profinet, which enable the PLC to communicate with other devices on the factory floor, such as sensors, actuators, and HMIs. Sixth is the monitoring and diagnostics. A PLC software can provide real-time monitoring of the PLC system, allowing users to quickly identify and diagnose any issues that may arise. And this was my part, Hujam. My friend, colleague Ahmed Badr will continue.
Hello, Hujam.
Okay.
Can you hear me?
Hello. Yes, I'm hearing.
Applications. PLC are used in a wide range of industrial applications, including manufacturing, assembly lines, packaging, and material handling system. Here are some common examples of PLC application: conveyor control, robotic control, packaging, machinery control, water treatment, HVAC control, power distribution. You can see the figure in the bottom. Here, a conveyor controller. Can you go to next slide? What are the benefits of the PLC hardware? Reliability, flexibility, cost-effective, easy to troubleshoot interfacing. What are the disadvantages of PLC hardware? Cost, complexity, limited flexibility, physical space requirement, maintenance, and obsolescence. Here you can see the reference, and after this slide you can there is a video, but there is no enough time. Thank you, Professor.
Okay, you are welcome. So thank you for your presentation. Again, I must say the more pictures, visual presentation, less text, huh? Not too much. So then let's come to the group, last group G. So is somebody from the group G available?
Yes, Hocam, we are here.
Okay. So please prepare yourself. 5 minutes break. I will be here in 5 minutes. Okay.
Okay.
So that means we will start 22:06.
Okay.
Okay. Okay, and now we can start. So, who's the first? I need the.
Hojam, I will start the presentation. My name is Umar Imran.
So, sorry, Omar, a moment.
Umar Imran.
Imran, you are the first, okay. So the second one.
I'm the second one, Hocam. Faisal.
Wait. Faisal is the second one, okay, Faisal. Third one.
Third one is Islam.
Yes, a moment. Islam, okay, understood. And the fourth one?
Fourth one
It's me,
is
Doctor.
Sorry?
Yusuf.
What is the name?
Yusuf Munir.
Yusuf Munir. Okay,
Yeah.
where is Yusuf Munir? Yusuf Munir, okay, this is the third, fourth, okay. So Yusuf Munir, and then next one?
Then is Muhammad Umar Khan.
Muhammad Umar, where is that? Muhammad
Umar Khan.
Muhammad Ahmed Shakir is in the group. Muhammad Ahmed
Yes,
Shakir.
I'm the last one. Yeah.
Huh?
I'm the last
Hocam,
one.
I sent you an email to add me in this group.
So the
Because I was late registered in the group, so my name was not there.
so you are not in the group.
You told
And
me.
wait, so what is your name?
Muhammad Umar Khan.
Muhammad Umar Khan. Wait. Muhammad Umar Khan. Mechanical or mechatronic?
Mechanical.
So in mechanical engineering, Muhammad Omar Khan, I couldn't see that.
You can check it with my student number.
So what is your number?
Wait, sorry.
Can you spell it?
2020.
Sorry?
I wrote it on the chat. You can check it there. It will be easier.
So I don't see that because I'm checking the list. So please read your number.
2202 04312.
Wait. 220
2
2, okay.
04312.
04312.
Yeah.
Last 431.
4312.
4312. 4312. Four, three, one, two. Four, three, one, two. And this is Muhammad Ahmed Shakir.
Yes, hocam, the last one.
But we are talking not Muhammad Ahmed Shakir, Musallam.
Yes, hocam, I'm the
So,
group G.
okay, but the Muhammad Omar Khan, we are, isn't it? We are looking for.
Yeah.
And hocam, the last one is Muhammad Shakir.
Last one, okay, but Muhammad Omar Khan is not in the list. I don't see that. One is to be registered.
I am registered, sir.
Since beginning the semester.
No, not since the beginning. I was late registered.
Latest one did you register it?
Like week before midterms or 2 weeks before midterms, something like that.
So you came late. You are not,
Yeah.
therefore you are not in the list.
Yeah, I
Where?
sent you an email to add me in this group.
Moment. Mohammed Umar Khan. Yes, okay, I remember it's here. Okay, so you are the fifth, isn't it?
Yeah.
Okay, so fifth. Okay, yes. It is yellow labeled, yes, in the list. Okay, so sixth, who is the
Name,
sixth?
yeah. Muhammad Musallam.
Muhammad
Ahmed Musallam.
Muhammad Ahmed. Okay, sixth. Okay, so seventh.
We have
No.
just 6 persons. hocam. There's no 7.
Sorry?
There is no 7.
We have 6 people in the group because
You are
some of
sixth
the
in the group.
yeah, because some members left the group and the other members we were not able to contact them, or like they were not
So-
able to contact us.
Okay, your group consists of 6 members.
Exactly.
Am I right?
Yeah, exactly.
Okay, then let's mark the others. Not available. Okay. So you are the 6. Okay, 1, 2, 3, 4, 5, 6. Correct. So okay, then we can start. Group
Hujam,
G.
can you please make me the moderator so that I can share the
Yes,
presentation?
I will do that. Yes, I will do that. Umar. You have the presentation. You have the documents to present, isn't it?
Yes.
Okay.
Just give me a minute.
Yes, you can start, Umar.
Just a minute, Hujam. The file is loading right now.
Okay.
Can you see the screen?
Yes, we can see it.
All right. Let's start. So Hello everyone, my name is Umar Imran and I'm here with my team. Our topic is going to be software. So software in mechatronics. Mechatronics is an interdisciplinary technical branch of engineering. It includes different components such as sensors, measurements, actuation, microprocessor technology, etc. In a mechatronics system, we have three stages. The first stage is the modeling and simulation stage. The next one is the prototyping, and the third one is deploying the system. We will be discussing about the
Omar,
software.
start from the beginning. You start from the 5th slide.
I started from the first. Did you guys not see that? Like,
now we can see it.
okay, I guess it works this way. Okay. So my name is Umar Imran, and I'm here with my team, and I'm gonna be present. We're gonna be presenting the topic of software. Software in mechatronics. Mechatronics is an interdisciplinary technical branch of engineering which includes integrated systems with sensors, measurements, actuation, and microprocessor technology. There are three stages of mechatronic system. The first one is modeling, then we have the prototyping, and the third one is deploying the system. We will be discussing about modeling and the software part of this mechatronic system. There are 5, depending on the requirements. The software are as follows: embedded software, control software, human-machine interface software, simulation software, and machine learning software. We will look into each of these types one by one. Embedded software. This is a type of software that is installed or it exists in microcontrollers in the mechatronic system. It is written in low-level programming languages like C and assembly. Embedded software is used in mechatronic system to control and coordinate various components. Next, we have the control software. Control software is used to control the hardware components such as motors, sensors, and actuators. In this software, we can give commands such as adjusting the sensitivity of a sensor or the speed of a motor. Control software is typically written in high-level programming language like MATLAB, Simulink, or LabVIEW. Now I'm going to hand this presentation over to my teammate Faisal.
Okay, Omar, thank you. So I'm gonna continue. I'm gonna be continuing the types of the software in the mechatronics. As he mentioned before, there is the embedded software, control software, human-machine interface software, simulation software, and machine learning software. So here the human-machine software, which is the HMI software, is used to provide a graphical user interface for users to interact with a mechatronic system. So the human-machine interface software is typically used in applications where the user needs to monitor and control the behavior of the mechatronic system, such as the industrial automation. So how does the human-machine interface software works? So it replaces manually the switches, dials, and the other controls with the graphical representations of the control process and digital controls to influence the processes. And it also allows the operators to start and stop cycles and also adjust set points and perform other functions required to adjust and interact with the control processes. Can you go to the next slide, please? Here we got the simulation software. It is used to simulate the behavior of a mechatronic system before it is built, which can save time and it can reduce costs. So these are the advantages of it. Simulation software can be used to test and optimize various aspects of a mechatronic system, such as its control algorithms, mechanical design, and the sensor placement. Next slide, please. Other
Can you
type
use
of
please the
software.
sorry
Yeah,
for interrupt. Can you use the total screen and the screen completely? But in the power presentation, you see on the down on the left say right
Jam,
side.
if I enter into that mode, the total PowerPoint's presentation mode, then you guys will not be able to see.
Can you just
That's a
try?
problem.
Maybe it will.
Why not?
Just try.
Yes, this one. I mean, yeah, correct. No, not this one. The next one. I did the last one. No. Huh.
Yeah, this one.
This one, yes.
Slideshow.
Yes, this one. Click this one.
Is it happening? I can't see it.
Bro, try from upside.
No, not there. So no. Here you see.
He can press it from the current slide.
From current slide, yeah.
From current slide down on the right side.
It's not working, maybe.
Jam, like I said, there is network problem and some problem with my PowerPoint version, so it's better if we use that method.
Okay, let's continue. Okay, continue.
Okay. The last type of the software in mechatronics, which is the machine learning software. This software is used to develop intelligent mechatronic systems that can be learned and adapted to the environment. Machine learning algorithms can be used to optimize the control of a mechatronic system based on real-time data from sensors or to recognize patterns in data from various sensors to improve system performances. Some machine learning tools, which is like Keras, Jupyter, RapidMiner, and Amazon Machine Learning, are the most famous machine learning tools here. And now I'm gonna go with Islam to continue the next slides.
Hi everyone. Here we are going to talk about the software function, the features of FloatSim software, interactive simulation. FloatSim allows both the convenient creation of circuits as well as their interaction simulation, not only state changes and component switches, which result from the system are calculated. Moreover, the user can interactively operate and activate switches or change over valves. Also, signals from connected hardware or via an interface from other program can be transferred. Flow system immediately reacts to such events and simulates seamlessly the altered system. Can you move to the next slide? Thank you. And here, a function like it shows us the way, okay, of the software function. Okay, next slide. How do these software function? Virtual measuring devices, in addition to real-life measuring devices that can be built into a circuit before the simulation. Float system offers virtual measuring devices, like it's shown in the photo. Float sim offers virtual measuring devices during a simulation. Multiple of those can be developed to show various state values, contrary to real-life measuring devices. Virtual measuring devices do not influence the circuit, but they simply indicate the values of the circuit as simulated by FloatSim. And here we have an example of how it shows. Thank you. And here we go to Yusuf. Continue. Thank you.
So
we will go with the applications of mechatronics software. We have the computer-aided design for designing structure or any shape. We have in the second one computer-aided manufacturing. It's in the process of like CNC machines that we can handle the structure or change the shape. We also have the simulation software, like we have ANSYS or Fusion 360 to test and try to customize our structure or material of piece of material, or we have embedded system software, we have image processing software, also we have data acquisition and analysis software, also we have human machines interface software, machine vision and artificial intelligence and machine learning software. Next slide, please. In the first one, we have the computer-aided design. It's a software to be used to create and modify and optimize designs in mechatronics. It allows designers to create digital 2D or 3D models of parts, like a CATIA. We also have a computer-aided manufacturing software. It helps manufacturers plan and control the production process of generating tools, optimizing cutting squeezeness, and setting up manufacturing process. Like many applications we have. We also have simulation software. It allows designers and engineers to test how mechatronic system or products works by creating computer models that imitate real world conditions, like we have ANSYS and many other applications. Now I leave you with Omar Khan.
So the rest of the softwares which are used, like embedded system software, it refers to the software program used to develop, test, and implement software in mechatronic system for proper functioning of the system, and is often developed with the mechatronic system itself. Image processing software is to analyze, process, and manipulate digital images in mechatronic systems. Data acquisition and analysis software, it helps to collect, analyze, and interpret the data from sensors and other sources. It is essential for quality control and optimization and troubleshooting, etc. Next slide. Human machine interface (HMI) software is used to create an interface between the user and the system. Through HMI software, users can interact with the physical machine or system by sending commands, receiving feedbacks, and monitoring operations. Machine vision provides a mechanism for machines to capture, process, interpret images to make decisions based on visual input. It is used in mechatronic systems for applications such as remote sensing and quality control. Artificial intelligence and machine learning. It is used to analyze data and identify patterns to help optimize and automate the mechatronic system. This type of software is used in prediction and decision-making algorithms, machine vision, and data analysis application. Next.
Hello everyone. I'm going to talk about advantages for software. Efficiency software can perform complex tasks quickly and accurately, saving time and increasing productivity in many industries. And the second, consistency software. Software can be performed repetitive tasks regularly and constantly, ensuring the output is always the same. And the third, scalability. Software can be easily scaled up or down to meet changing demands, which is essential for handling large volumes of data or requests. The last one, cost effectiveness. Once developed, software can be distributed and used by many people at a relatively low cost, making it optional or worthwhile investment. Next slide. And here is the disadvantage for software complexity. Developing and maintaining software can be complex and time-consuming, requiring specialized skills and expertise. Security risks. Software can be vulnerable to security threats such as viruses, malware, and hacking, which can compromise data integrity and lead to financial losses. Dependence. Many businesses and individuals rely heavily on software, which can be problematic if it falls or becomes unbelievable, resulting in lost protectivity and review. Compatibility issues. Software may not be compatible with a different operating system or hardware, leading to frustration and limiting its functionality or users. Thanks for your attention.
So, dear students, you are talking, okay, you talked about software, but software, did you participate to my lessons?
Yes, Hojam, we did.
So, but I mean with software we use for programming of PLCs, not the general software, what is available, what's used in the technique of the mechatronics. So this software, I mean the programming software we used for the programming of PLCs.
Yeah, we spoke about that in control software. This part.
Like statement list, ladder diagram, function chart. You didn't understand what I'm talking about. So, okay. Any question? Okay,
No
the presenter, I will check once more who make the presentation. First, Umar Imran. Second, Faisal Hisham. Third, Islam Said. Fourth, Yusuf Munir. And fifth, Muhammad Umar Khan. Sixth, Muhammad Ahmed Shakir Musallam. Is correct?
Yes, Hojam.
Yes.
Okay. So, thank you. Okay. Bye-bye now. I think.
Excuse me, Professor. Can I ask you a question? What are we responsible for the final exam?
You are responsible for final exam. You mean the principle of mechatronics?
Yes. What are we responsible for? All the topics?
Yeah. Yes, all topics.
All the topics that you applied on Blackboard, right? The section.
Yes, yes. Yes,
Thank
right.
you so much.
Professor.
Doctor,
now,
is there anything that we have to focus?
Professor, can you hear me?
Yes, Zapan, I'm hearing you.
Yes, Professor, I have to give my presentation. You told me to wait till the end.
Okay, Zapan, you can start.
Can you make me a presenter and I'll share my screen and tell you?
Yes, yes, I will do.
Doctor, is there anything specific we need to focus on for the finals?
No, I will upload the hardware. I think hardware, you have the software and hardware. I will upload into the system and you have to work. This is all.
Hocam, you upload hardware but no software.
Yes, I will upload. I will upload.
Okay, Doctor, thank you.
You're welcome.
Can you see my screen, Professor?
Wait. Please, so. Okay, Zapan. So not the presentation, but I see your screen, yes.
Okay. Now I think you see the presentation.
Yes, I see also the presentation. Correct. So.
I can start?
Yes, you can start and as quick as possible.
Yes, Hojam. I have text, but I will not read it. I know what I'm talking about, so I will just explain. There are pictures. They come a little bit later, and it's not very big. I will go through it quickly. I also did my presentation on the software because I was a part of the previous group. You said do it for the same software for mechatronics. I said okay. So I'll have the design, their types, the design features, the interface system, the architecture, the languages, and other specifications, the functions, how they control machines, their sensors, actuators, and how they analyze data and gather reports. And as far as applications of mechatronics softwares, you can use them anywhere because any engineering software, you can use it for a mechatronic system. But it's mostly used in industrial automation, robotics, concepts for smart cities because they have robots, and transportation systems because transportation systems have the most common synergy of the different engineering fields. There'll be the advantages, the benefits, and related applications, and the disadvantages where we don't need. I'll
Okay,
skip this as I will not.
Please, Zapan, please
Yes,
don't read the text.
I'm not going
Go
to.
fast,
I
go
will not
fast
read the
and
text.
explain. Okay.
Yeah. This is just to this text is just to expand on this, what a mechatronic system is. Mechatronic system is a combination of computer, control, mechanical, and electrical. So the software is mostly about the computer and control systems, but we can use it to manipulate mechanical and design electrical systems also. This is your basic mechatronic system model. There's a mechanical system. It has sensors, signal conditioners, analog to digital, and then your software controls what the sensors gather and then influence the actuators to manipulate your mechanical system. The softwares are mainly responsible for the controller part of a mechatronic system. So this will just focus on software engineering. These are the different types of softwares available that we use when we're doing mechatronics work. And this is important because whenever you use a software in a mechatronic project and you need to make either an independent software for your PLC controllers or you'll use an existing system, you have to use a thing called a V model. You check your requirements, you design your system, design the software architecture, make your modules, code, and you carry on through your testing and you keep back and forth checking. This will be important later. So my understanding of software for mechatronics comes into two types. You have modeling and you have development. In modeling is your computer-aided design where you make your mechanical systems, your electrical systems, and your combination of both mechanical and electrical, like a SimScape, which you can make your physical portions of electrical, mechanical, and fluid systems. So these are the main types. The other important type of mechatronic software is your development software. That's where your PLCs get coded. That's the mathematics in your models. That's your parts box. That is your C+ or JavaScript programming of your circuit boards. And those are mostly in MATLAB, but there are other ones like that. Those are the two types of design. I put a link for the mechatronics section of MATLAB over here if you or anyone later wants to see it, but it looks like that. Now, I'm not going to read this, Hojam. I just put this to show you that when you are programming your PLC specifically, or you're building a code for your mechatronics software, you have to include these things, which are basically data structures. You have to have a user interface design. Multi-threading means that multiple users at the same time can use your software on your controller. And you have to make sure that the software has its specifications, what design principles, what's the agile development. Once you've done all that, then you need your testing and maintenance and all what that means. And then afterward, you've done your testing and maintenance. Modern softwares need your internet APIs and cloud computing, which is the self-checking system and self-diagnostic system, and other people can change it. So now that I've told you the designs, I'll show you what those softwares look like. They're just images on Hojam. They're just example codes, what it actually looks like. This is SolidWorks. Maybe you know it. This is the mechanical part when you're building software. This is KeyCAD, that's your electrical component of your circuit board, or if there's a hydraulic actuator that's electronically operated, then you need a software like this so you can monitor and look and build it. So this is what they look like. And this is SimScape, which does all of those. You have the PLCs and the actuators and how they'll move and how they interact. Like in your lectures, Hojam, you know, this is what the softwares do. I forgot what this is, but this is also monitoring its control, its electrical functions and signals. I will come back to these pictures because they are important for the function. This is a Fusion 360, the robotic trace for mechatronics and software. Now, I'm not going to read this, Hojam, don't worry, but the function is very simple. You, in any mechatronic software, whatever the parts are, they start with the geometric model. You use that geometric model into your project. Then you need to make a physical topological model. That means that's when you start to actually see a unit. You need to add the mathematics to the unit, and then you optimize and analyze and repeat this process. That's how a mechatronics software actually functions. When we use AutoCAD, or even the program that you use in your lectures, Professor, this is how they're actually working in this image. This is their step-by-step process. We're out of time, so later on, if you want, Professor, you can look. But every unit has its mathematical system behind it in the software, and then we'll have its 3D, 2D geometries, and they get put together and presented, and you get to put those together. That's how it functions. More on that. Also the same thing. This is what the software is tracking when it puts things for you. So advantages, the most important advantage of a mechatronic software is we can three-dimensionally visualize what we're going to build. Of course, we can also use it for research, but the most important thing is we have geometric and functional dynamic behavior of their mechanical parts, because that's what we need to know. The other more unique advantage of mechatronic software is reuse and easy exchange of solution element objects. That means we can keep using the same parts or different actuators or different systems or different connecting ports again and again in different situations, and also because they're software, so we can copy the software onto USBs and transport them around easily and put them on other computers. Those are the most important advantages of the software. And our modern technology, we can't build anything without software. The other very important last advantage I'll say is it does save us a lot of money in testing, because instead of having to think of something and then build it and manufacture it and see, we can get a very accurate picture of whatever it is we want to make on our software and see how that works and get rid of a lot of the testing process and come up with fewer prototypes. As far as disadvantages, the most critical disadvantage of software is that current software are not fully able to take the physical mechanical models in real life and make them fully accurate into geometric models. So what I mean by that is that the mathematics of software for 3D design is not complete yet. But as our technology improves, we'll get closer and closer to not ever needing to make a prototype. That's the main thing. The other problem is software is more than half of your development costs in any situation. Software changes very rapidly in our modern technology. And a disadvantage of software comes in its application use. For example, if you're going to make a software for the pacemaker in a heart.
So Zapan,
Yes,
sorry for interruption. So
problem.
I expect quite different. My expectation was quite different. I expect that you talk about the PLC programming software, not general software. You are talking like the previous group. You are talking about the general software. So in my lesson, we talked about the software we use to program for programming of the PLC, like statement list, ladder diagram, function chart, and this was my expectation. I appreciate your presentation, but it is not the, I mean, this is out of the target, huh?
I understand
Sorry
that,
for that.
Hojam. Then I misunderstood because I know in your lectures you talked about PLCs, but the topic said mechatronics software, so I assumed wrongly that you want all of them, but it's okay. I mean, I did what I could, what I understood.
Okay, thank you for your presentation.
That's
Any
it, Hojam.
question?
And, no, that's it.
Okay, thank you very much. So then, bye-bye.
Okay, thank you, Hojam. Bye-bye.
Bye-bye.